Hi, in this video, I'll discuss about the SAS proc discrim. Proc discrim is used for discriminant analysis. So what is a discriminant analysis? Well, discriminant analysis is a classification technique which is used to classify uh, observation into different groups. This is similar to this technique is very similar to the logistic regression technique. The difference is that in logistic regression we only have two categories, wherein discriminant analysis can be used for multiple categories. Um, there are of course other differences, but the purpose is pretty much the same, to classify observation into different categories. Um, to illustrate this, I'll take an example. I'll take the iris data, which is very famous for any classification problem. So iris data has got uh, different types of flowers, and based on the characteristics of flowers we will classify them into different types. Okay, so we have the attributes of four types of flowers. So let me show you the data set. So we have got four types of flowers, the iris species, Setosa, versicolor, virginica, and so three, in fact, not four. So three types of flower species are there, and the corresponding attributes: length, sepal width, petal length, and petal width are there. So using these four variables, we are going to classify the observation into different types. Okay. So like any other modeling, wherein we use a trained data to train our model, then use the model to in the test data, to do the classification for the new observations. So the syntax is like this: proc discrim in data statement, and then the input data set is there in the work library. You can get it from the SAS help library. I have taken it from the SAS help. The option distance will tell you the Mahalanobis distance between the different classes. ANOVA and MANOVA are the tests to see whether the mean, the corresponding mean of the attributes across the different classifications is same or they are different. And then you use the cross lister option to see the error percentage. I'll show you on the output in the cross lister, wherein you will see the misclassification percentage in the output. The class is species. So class, this is like pretty much like the dependent variable in a regression type modeling. And in the var statement we have the different attributes. Okay, so these are like our independent variables, not exactly independent variable, but yeah, similar to these things. And when you run this, you will get an output like this, starting with the class level information, the prior probabilities, like probability of an observation getting into one class. It is all same for all the observations, because the count is same. So this is prior probability with absolutely no help from the attributes, so it is purely random. And then the square distance. So this is like a correlation type. So more is the distance, more is the difference between the different categories. So virginica and setosa has got a distance of 178. So they are very different type of flowers. Whereas virginica and versicolor, they have a distance of 17. So they are very close to each other. They are very similar type. Okay, so that's how we interpret the square distance. Then model statistic, like any other model output of any other technique. Then the p-value that the Mahalanobis distance is significant or not. And you can see most of the cases less than 0.05, hence significant. So the Mahalanobis distance that we saw here in this matrix is significant. So classification is justified, or there is a degree of difference between the different classes. So that's what it says. And then some more univariate test statistics and multivariate test statistics. We have also got R square, p-values, a-value, just to see how much contribution, or whether there is any contribution to the classification, is there for a particular variable or not. For example, sepal length is there. But looking at the p-value, we can say that, oh, this is significant. That means sepal length does contribute towards the classification of the flowers, or it has an impact, right? So that's how we interpret that. R square cannot be explained the same way that we explain in regression, but yes, this is a measure of model efficiency, or when you validate a model, when you compare models to find out which one is the best model, you can always check the R square value. And then linear discriminant function analysis, just to see the direction of impact. There cannot be any causal inference that can be drawn from this, but yes, it helps for classifications, and these statistics, you can see, will be used for classification of new data, and we will see how we can do that. This is the classification table, you can see. You can see that the misclassifications happening. There are so many cases where you will have a misclassification. So 50 setosa have been identified as 50, so it's 100% classification, so there is no error here. Whereas here there is some error percentage happening. So versicolor is being classified as versicolor 96% of the times, or out of 50 cases, only maximum of 48 cases have been identified correctly. So there are 2 cases which are not identified correctly. So what are the 2 cases? So versicolor has been identified as virginica. So two versicolars, or 2 observations have been misclassified. So in that way we interpret this table. And just to see what is the overall misclassification, you can see the error rate. The error rate is well, it's 2%. 98% of the observations are classified correctly. 2% of the observations are misclassified. So that's how you use discriminant analysis to the classification. But the interesting thing about discriminant analysis is that for the independent variables, or in the var statement, you can only use the continuous variables, not the dummy variables or any ordinal nominal variables. Okay, so that's one difference between the logistic regression, or the ordinal logistic regression, and the discriminant analysis. Normality is also very important to make sure that your independent variables are normally distributed, at least near normal, if not fully normal. When you want to use this model to score the new data set, or a test data set, or a new data set, completely new data set, how do you do that? So you use the test data option here, test data, and say it's a new data you are using. Okay, you don't have a new data, but yes, if you have a new data, then use this option, test data equal to, and then mention the new data set that you want to score. So using this model, whatever statistic you have finalized from your trained data set, your trained data set is iris, you will use those statistics to score the new data set. Okay, so that's how you use proc discrim to do the discriminant analysis.